Right, that sucks. That sucks. Well, I guess we'll live with it. That'll do. So, that's a bit problematic. So what happened is my webcam can only get configured on Windows, and for some reason when I opened up the filter settings, it decided to probably change some of the webcam settings, and it's probably flipped it to a different mode or whatever, I imagine. Maybe. So I'm gonna have to probably do something in Windows to fix it again. But that'll happen obviously off stream. Right, so last stream we got all of the rules sorted out for the validation, and we merge the database, merge the encoder file, which defines a bunch of data types that you want to encode into a file or something. We've got all parsing. We've got to make in a database file. So now what we want to do is make sure that the system that we've built, the encoder system, when we run it to code generate, we want to make sure that all the steps that verify that the file and make sure it makes sense works as intended. So we have a screen here for the documentation, and the documentation goes over all the rules. So I want to read over this, make sure we get all the rules, and then we can simply correct the make sure the rules are implemented in the program, and then test it all out and make sure it all works. And then in future streams we can do the code generation for these encodable types. Hey there, Devastated, how you doing? Welcome. And I'm so bummed out about this. Yeah, I guess we just gotta live with it, maybe. A bit bloody annoying, not gonna lie. See, if I change it anymore, I cannot believe it messed up. This is not, it's only available to SDR. Oh. Okay. I just clicked this button here to select it, that's what happened. Excellent. Alright, we're back. It was like that before, wasn't it? I'll do. Right, that's good. Did we mess around with some of this stuff? Oh, I'm so glad this is fixed. Excellent. Right, I'm happy with that. Put me in the right place. I don't know what the time is, right? There we go. Cool. So yeah, let's read over this file and just make sure that we've got every piece of the validation implemented, because I've definitely missed stuff. Let's open this can of Coke as well. Hey, Devastated. Good. Yeah, I'm not doing bad. I'm pretty good. Been super busy today. Very busy on many things. Yeah. But been a good day. Successful day. It's been a lot of fun as well. But yeah. So basically we've got basic types, vector types, Yeah, we also want to write down if we can't do some of these steps now, because some of these validation steps are probably done in code gen stage. Well, not validation, but just stuff that requires conditional things in code gen. We should write those down. Right. Maybe we should go over some of the... Right, these are some of the to-dos. Let's just remember these. Make sure VLA index is handled correctly in type merge. Right, that's something to do today, probably. Unions in text files are ambiguous, probably need a tag. I've already done that. Make sure make the pack type min-max values work as expected for low precision. Float that types. Right. I know what that means. That's good. We'll keep that one there. Almost for most places that's been done. So the next thing to look at is the right, so the VLA. Yeah, so when we do that VLA thing, so when you have a variable length for A, you have the ident and also a field index. Is a field index a good idea? We could have a pointer to a field. It's something we could do rather than a field index, and then look it back up. Because some of these enums, so those pack types will reference an enum value, isn't it? Yeah, maybe we'll do like VLA. What structure this array belongs to. And then, well, I could always just find the field. Now, we'll store the strut in there, I think, maybe. Yeah, okay, that's what we're going to do. We're going to say type VLA strut. And then you just have the VLA strut field. So that way we can patch these when we merge the encoder data description file with the database file. So this is going to find it. VLA strut type equal S. Then there will be a strut field. There'll be a S strut fields other field index. Is that just a find? Then we can make this a bit better. There's a thing called type field find or find field. So we're passing the type, which is S. Nah, we'll leave it to do it this way. And that's just taking the address there. So when we do a merge, type table merge, that's merging the regular ENC file into the database one. There's a piece of code when we copy over all the structures, I think. Yeah, if it's an enum, if it's a structure or a union. So if it's in dev mode, it just does a copy and does a bit of a translate. Right. So I guess if we're translating arrays, you say if new type array dot strut type, meaning you have a VLA, we'll translate that over. We first get the field index, which is the difference between new type array field take new type array strut type structure fields. I'll tell you the difference between those 2 pointers. Then we translate in strut type over. Cool, and then we reset up. Did I post those live on the Discord? I don't know if I did. We'll reindex into the fields array like so. Right, my one concern though, I did post, good. My one concern is that you'll probably, at this point in time, you've already, what have you already done? Okay, so the destination type's already been changed. It now points to the source one. So that will be okay. But then here we're saying if we're in text mode, we go over all the fields and verify, make sure everything makes sense. We don't break any rules. If you change types, that's an error. Then at the end, we just copy we do that same technique where we just copy the pointers over and patch the types by translating them, whereas the binary one never changes. Okay. Well, so really those don't need to get updated really, I don't think, because it just points us to the same place. Should be okay. But I'll do it anyway, just in case code changes. That should be okay. It's work that technically doesn't have to be done. But we'll do it anyway. Yeah, we'll do it. Just in case the code changes. Right, so we've done this to do now. Make sure the VLA field index is handled correctly in the type merge. It's now just using pointers, which will be used for the code generation. Check to make... Right, we'll leave that one there. Okay, so let's read through the documentation. We're going to try and find anything that needs to be checked in the encoder system when we run it to generate data structures, encoding and decoding code. We're going to verify that the encoder types have not changed and broken some rules, and other things as well, like depending on what targets your encoder is for, like do I target run out to files, do I target the GPU? There's certain restrictions that you have sometimes. So just make sure we follow all those rules. So let's see if we can find any of them. So structure types, they're just just like C, but they've also got support for a variable length array. So the variable length array type, structure types support variable length arrays when array count uses a field name instead of an integer. The VLA field will be replaced by U32 relative byte offset. From the field's memory address, this can be used to access the array using the code generated function. Is an example of that. Right. So we'll get code generated like that with the VLA byte offset, and then you use the function to get the pointer. So there is actually a restriction, but I guess we can wait till we get to that when we read it. But there is a restriction where you cannot have these on GPU, I think, and other things. We'll see. Right. Packed types. Oh yeah, the reason why we're waiting is because down here there's a section where we go over all the target features, and VLAs is one of them, and it literally says it's unsupported here. So that's something we will get to. So packed types, these are basically our version of bit fields. Packed types only work on structure types, they act as supercharged bit fields. We want to be able to express decoding and encoding integers, floats, and enums into smaller series of bits. The packed types allows you to express how many bits you want packed down followed by English. Allows you to express how many bits you want to pack down, followed by let's put a comma in there, followed by a min-max value. This will allow the system to generate unpacking/packing functions for your structure type automatically. Whoa. Field A is a regular field. Field B is a 16-bit and that gets packed down into 8 bits. Within a range of 100 and 300 inclusively. Field C is a float 32. It gets packed down to 24 bits in a range of 0 to 100. So that is a bit out of date. We did change it. 21 bits. And then we should really finish it off with field D is an enum that is packed down into 3 bits. Now, what's the range that it does again? It'll do the min and max value, isn't it? Yeah. With a range from its min and max value. Did we express that the min and max? Yeah, we did. We wrote that code 2 streams ago, I think, where if your min and max value goes outside the range. Yeah, we saw that. That's pretty cool. Right. Okay. Field D is an enum that is packed down into 3 bits with a range from its min to its max value. From its min value to its max value. Right. The more bits, the more precision. The less range, the more precision. Yep, that's That's correct. So bit field T means that bit field's word size is aligned. The bit field's word size and alignment will be of type T, where T is a basic type. Bit fields can span over multiple words at the cost of unpacking. Can span over multiple word boundaries. Can span over word boundaries. Bit fields can span over word boundaries at the cost of unpacking such packing performance. So you can work that out quite easy, right? If it's a U32, well, if you go over the 30, if your integer that you're packing down goes over the boundary of the 32 boundary, you can easily work that one out. So for the user, it's very easy to catch that. It's a bit like padding, right? You can work out the padding yourself just by reading the code. So we're able to express stuff in a very powerful way this way. If T is not specified, then T will default to U32. Yes. So I believe we already wrote that in the yeah, we already parsed the bit field directive. We've still got to test it though. Did we do it? Yeah, should we test it? Yeah, I've already tested the packing stuff. I know that for sure. So what can we do? Right, let's do here bit field U8. This will work. This should work. Ooh, what the crap happened here? Somebody did not put a semicolon down. Right, apparently that ran okay. Parsed okay, apparently. So I put something else in there, like a vector of things or whatever. Let's do a vector 2 of U8 segfault. Well, I think that's because we use context aware printing somewhere maybe. Oh, right. These are meant to say dot star. There you go. There you go. That's cool. So the other one is like, yeah, if it's not U32 and it's not supported on GPUs, I think we've already got that checked there. That's good. That's good. Right. So I think we're okay. Yeah. So this will just generate functions like this to get fields, right? So this only occupies one U32. So only will output one U32 and you get this. That's pretty sweet. The union type, as you can see, best example is very similar to C, like unions. Unions are untagged, right? Right, so I didn't mention that we need so the tag field, right? Did we mention that? Yeah, so we've not put it in documentation form. So what we would need to say is where is there's a text feature. I think it's just called CSON. All right. What else? Yeah, it talks about default values. What about... Hmm. And also say in CSON, in text encoding, when using text encoding, unions will need to be decorated with key tags with key directives and the field where the union is used needs a tag directive. Otherwise, the encoder generated this is so that the generated decoder / encoder can know what type it is expecting the union to be. This is not a problem for binary files since it just copies the raw bytes. Cool. So we need to get an example of that. Thankfully, here's one. We'll just write a small version. I'll need a damn enum, don't I? We'll make a smaller version, obviously. We've only got dragons and pigs in the enum. Yeah, there you go, dragon and pig, whatever. So you put the key in there like so, and then you can say and type. Data tag and type. Boom. Oh, did I not change my let's get rid of that bit filled thing. Cool, so we'll get to reading that in a bit. Let's just carry on. So the unions do have to have that tag thing, but I guess we're not going to specify it here because it is a thing which is required because of a particular feature that you turn on perhaps, rather than just being needed all the time. Enums, you know, as you can see, by this example, is very similar to C, and we also support C. C23 underline type specifier, but we generate this with a type def as we don't use C23. So there it is in the, yeah. And here it is, the code generated. Hexadecimal text encoding, structs and union fields that are in integers can specify that they should be encoded as hexadecimal when being encoded as text. CSON, here's an example. Yeah, maybe this could actually be moved to the text section. Like, let's move that around. Bit of a silly idea putting it here, I think. So where's the text CSON? That's the union thing. Default values, but we'll keep it simple. Here is the example, let's delete all that. Cool, so that's now moved out of the way. So let's go through here, see if we find anything. So this is the whole target sort of thing. Targets are ways of specifying how you wish the encoder system, how you wish to use the encoder system with this English. With this ENC file. Each target that is enabled can enable features in the encoder system as well as disable features because they will not be compatible with that target. E.g. text CSON is not compatible on GPU. Targets cannot be added or removed from the ENC file. You must specify them at the top of the file. So we've already got that checking code in. We check to see if the targets differ with the one in the database file. So the database, so we have a database file that gets generated the first time and it gets maintained. So this is the one which we last generated. And at the top, it also puts the target. It looks exactly the same, but it's a bit more explicit, the ENC file. So if this differs from the one in the ENC file, then it reports an error. So we can actually test this. Let's make it support GPU all of a sudden. The target directive cannot have text format if GPU target has been specified. Right, so let's get rid of text. Can I have default values if text format? Okay, so where's the, oh, it's default here, isn't it? Here we go, here's the error. So in the database, it's file binary text, and then in the file we've changed it, and it's like they cannot change. Right, so that's another thing. Did I answer the question with default values? And I think I did. Yeah, you can have default values on union things. You can, of course, you can. Right, that makes sense. Okay, let's keep reading. Right, so we've verified that works. These sets of target modes mean that we want a version file that possibly gets upgraded. It can be copied to the GPU and used there. So fastest GPU binary. These sets of target modes mean that we want a version file that possibly gets upgraded that can be copied over the network, file network binary. This target mode means we want to purely where is it? This target mode means we want it to purely be okay. This target mode means we want it to purely be operated on in GPU memory. Say a bit better. To purely means we want to sort of /unpack /pack data in GPU memory. Cool. So target mode file, we have an editor where we want we have an editor where we make custom assets and save these out to disk. We also would like to add more features and make changes without losing assets that have already been made. We would also like to be able to use text files most of the time in development so we can visualize the data better and be able to ship binary files of the assets for speed and size reasons. When we use the file target, a single ENC file represents a single file type. You must specify the single root structure type with the roots directive. So we have actually got that restriction in, I remember. We can test it out though. So let's make 2 roots. Root directive has been declared multiple structures. Excellent. What about if it's not got a file? Let's double check we've got that in there. Root. Yeah, see, it's allowing root without. So you can only do this if. Hang on a minute, what's going on here? Yeah. If file target flags and target flags file. If it's not got file, root directive can only be used when file is a target. Use when file is a target. Yeah, something that we were missing. Cool. The generated code also contains the header field with the magic number version checksum inside it. Right. I should really be writing stuff down that I want to remember for code generation side of things. So I've not got anything yet. I think this is my first thing. Let's write that down. So this is going to be the to do code gen. Yeah, so for code gen, we want it to be, ensure that the root, if root first field is header, insert field 0 binary header. So we should really probably change it from bin header to like ENC binary header, maybe bin header, something like that. Cool. All right, I like that change. Version check. It's not just got the version, it's also got the git commit hash. Just in case We want to make it support multiple branches in the future. Every file needs a magic number for ensuring that the correct file format is being processed. The magic number is always a 4-byte accessible number. You can specify the magic number. Directive below the target directive. So I've got a comment there. Have we supported comments? See if that'll work. Expected a new line after the argument. See, this is not good. We'll quickly check our parsing code there. Because we didn't do a tokenizer because I wanted to just like get it done quick. But it has its own problems. So yeah, I wanted to make sure that there was I wanted to make sure the new line was checked. Or there was at least a new line. Because otherwise you can do these hash whatevers all on one line. So, or I could just get rid of that check and just, it'd be like, so that bug will exist, but it's not really a problem. Because then we will support comments. I guess let's do that. Right. Alright, that apparently ran successfully. Right, skip back to the docs. So, what else? When writing network packets, you benefit a lot from packing structures down before sending them over the wire. This will help you send less data and reduce the amount of data that goes missing and has to be resent. You also gain access to versioning, so you can communicate correctly with other clients on the same version. When reading and writing packets from the network packet buffer, these will cast the byte stream into the code generated strut and manually process the packets themselves. CPU target is for when you're writing data infrequently and reading the same data multiple times across many threads. You benefit from packing structures, become more cache friendly. Yeah, I don't really see me using this one, but I might, so I put it in there because it really doesn't add any, there's nothing else that needs to happen basically to get it to work. It just completes the whole design a bit more as well. GPU target. On GPU, you usually read the same data across different compute units, and this uses up space in caches. Also, memory bandwidth is the first major problem to solve. So packing data down as small as possible is usually the way to go for a lot of GPU algorithms. Manually unpacking a pack-in is error-prone and takes time, and this is the main problem the encoder system solves for GPU use cases. But if you mix it with file, it also gives you versioning, right? Because you can mix these targets around basically. Right, so this is where we get into the meat and potatoes of the error checking, which is these target features. Each of the targets have features that get enabled and disabled, or unchanged. Features are aspects of the encoder system. Maybe I should call it right encoder there. of the encoder system that change depending on targets. Each feature can be enabled. Feature is enabled for target. And features enabled by the target unless another target says it is unsupported. Unchanged feature is unsupported. Sorry. Feature is supported unless feature is supported and left unchanged by this target. Feature is supported by this target, but this target does not enable it. Does not enable the feature. Something like that. Feature is supported by this target, but this target does not enable the feature. Feature is not supported by the target and completely disables the feature. So the GPU does a lot of that because it just doesn't support a lot of things. So for VLAs, files enable VLAs support inside structures. Networking is unchanged, GPU is unsupported, and CPU is unchanged. So what we need to do is when we actually use a VLA in the generator, if array type if it's not a digit, then if it's not a digit, then we process the identifier and set it up. Now we've got to be careful. If the VLA feature is not enabled, we error. We'll take this. File. There's target feature flags. So what we've gone and done is we've gone and taken those features and made a feature flags enum, where we've got each of those features as a simple flag we can just check. So we've got VLA one here. So if VLA is not a feature, VLA feature is unsupported on GPUs because that's the only one that was on GPU target mode. It's unsupported when targeting when using the GPU target. So I'm going to put a hint in here. It's pretty obvious. Cool. Pretty nice. Yeah. Alright, so that error check is in there. Let's see if we can find anything else for the VLAs. Variable length array inside struts are only enabled by the target file. Oh, I didn't. Since they work by encoding a U32 relative offset from where the field is. For files, this is very easy to achieve since we can bump allocate arrays after the root object. Right, this reminds me of that builder thing, isn't it? Yeah, that's defined down below, I think, a bit more. When just used with, when just used with the net target, the packet size is only, I could say it is not used for net target mode, or it is not enabled. It is not enabled by net target mode, as the packet size is only 64K. So other techniques just work out better. We can always change our mind on that. VLAs. And for GPU, buffers are a single type, so supporting it will only really work if we did an untyped U32 buffer where we reconstruct everything, and I don't see the use case for this at this time. It seems like it'd be quite a lot of faff basically to support it, and it'd just be weird code generated stuff. Just be super weird. Right, so that's a good one. Text is the next one. I'm doing capital letters everywhere, so let's put a capital there. So text support is enabled by files, by the file target mode, but the net target mode is unchanged. GPU is unsupported and CPU is unchanged. So very much like the VLAs here. So we've got to be careful. Oh yeah, we saw that error, didn't we? We tried to change it. Target directive cannot have text format if GPU target is specified, right? Yeah, we already tested that one out. So we already know that it's got that check there, which is pretty cool. CSON, also known as the C-like JSON, only really has a use when serializing out to a file. When reading data from a text file, all values might not be present. Solve this, you can either do nothing and let it use the default value for that type, or use other values like so. So we've got rules where, so we parse this up as a string. We don't really, so we just parse it as a string, and we paste it in basically, and if not, this would just be zero initialized. So we'll probably mem set the whole thing or something. And you can override a structure one as well. And that is valid C syntax. That'll just be copied and pasted in, and it should just work. Default values are just parsed as strings, so there's no error checking done part of the encoder gen system. The string is parsed. Is pasted in as text decoding as the text decoding code is generated. Yep. Unspecified default value. These are the rules around it basically. If it's a basic type, it's zeroed. If it's an enum, zeroed. If it's a vector, it's zeroed. If it's a quaternion, it's identity. Matrix, it's identity. Transform 3D, it's an identity. Structure follows strut. That's a bit strange, isn't it? Struts follow their field default initializers. Unions are initialized to the field which follow the type of the field that the default tag specifies. So your tag will be initialized to whatever the tag specifies. So because it's text, you need those tag fields. Maybe we should move that up. Yeah, we should move that up first, maybe. Maybe we can move the hex one there. Right, so I guess we've read that now. Did we read that in the end? Unions follow the type of the field that the tag specifies. Yeah. So because... Oh shoot, what the crap is this? Right. I missed copying that around. Okay, so when using text encoding, unions will need to be decorated by the hash key directives, and the field where the union is used needs the hashtag directive. This is so that the generated decoder and encoder can know what type it is expecting the union to be. This is not a problem for binary files since it just copies the raw bytes. So we've got an enum here with a dragon and pig, dragon and pig structures, union, which unions the dragon and pig strut, and it says that the key is dragon and the key is pig. And then when you specify a strut here, you have a tag type, which can be bit field encoded if you want it to, down to 8 bits. And then we'll let me put another thing in there, just so maybe I put like some other data. For crying out loud, support my tabs. Right, I gotta remove all these tabs now. Yeah, so we'll put another one in, we'll just call it like E32 B24. See, could we want to like shorthand this? Or you just specify min value. You probably best be explicit about it, I think. It's not really... Finally. It's inclusive in it. So we're just showing that we can pack... You can pack the... You can pack the tag along with other data, which is the benefit of doing it separately. Yeah. That's cool. Right, structures union fields. Their integers can specify that they should be encoded as hexadecimal when being encoded as text. You just put the hash hex thing there. Sweet. You don't need a type def. We don't support type def in the encoder file. Other than that, it's basically the same syntax and default values in these directives. When reading a text file, yeah, we already read this, right? This was okay about the default values, right? So these default values, let's just double check we parse everything correctly. Yeah, if it's not text, error, skip, and then just capture it. Yeah, seems all right. And then we trim it as well. That's all right. Okay, so it captures a string, and we'll just print that back out. Right, so we're on to versioning now. See what else we got. So after some of these features, we've actually got the decoding and the versioning a bit more documented, right? Okay. Right. So the versioning is enabled by the file targets and the net targets, and it's left unchanged by GPU and CPU. So what we need to do, because there's that dev mode thing, right? Dev mode can only be enabled if you actually have versioning. So we do have to be careful about this one. Oh, I've already got it here. Look at past Henry Go. So the target feature flags do not have version. The magic directive can only be used when there is a file target. That's a clear copy paste. The dev directive can only when there is a file or net target. Dev upgrade. Oh yeah. Yes, that's a good error. I'm glad we called that one. Sweet. File target needs versioning so we can preserve assets. Let's go back to that. Net target needs versioning to ensure other clients are on the same version so they can communicate. GPU and CPU targets alone purely work on types that are released in binary code, so no versioning is needed at all. Version upgrade is enabled by file target types. It's left unchanged for networking, GPU, and CPU. The main purpose for the file target is assets that we mainly edit in the editor. We need to be able to edit these types easily while developing new features, but also provide a way to upgrade old assets to the new version. Net will only need versioning to ensure other targets are on the same version, GPU and CPU types. targets are purely designed with what is released. Released in binary code, so no version is needed at all. Yeah, so we'll get into more of the details of the versioning stuff. There's more comments down below. This is just mainly talking about the features, I guess. But yeah, we did check. Wait, what about upgrading? Yeah, we're gonna be okay. I nearly missed something there. When we do this directive here, dev directive and specify upgrade, you can only do upgrade if you have the upgrade feature. Version upgrade, so that's not specified. The directive can only be used when there is a file target. Right. Because otherwise versioning is not enabled. No upgrade is what you'd have to do otherwise. Cool. Sweet, that's good. I'm glad we caught that one. Packed. So packed is enabled by files. Wait a minute. Did we check hex? Yeah, we need to put an error around hex. Yeah, so there's no text. Hang on a minute, what's going on here? Yeah, so if text is not specified, the hex directive can only be used when there is a file target, right? Not, or it's not really that, it's the encoding, actually, isn't it? Gotta be really careful about this. Oh, I bet. Oh. Right, what flags we got? Format flags, that's it. Format flags text. So if it's not got a text, format flags can only be used when targeting, when format a text format, e.g. file text. Right. That makes a ton of sense. Yeah, so tag we already caught, right? If you don't specify a tag, we've got the conditions down here. We can double check those. Yeah, I think I've already done it, right? But I don't put a key there. Missing key directive, yep. And I don't put this because I already tested it, I think. Yeah, missing tag directive, perfect. Oh yeah. Okay, so the next thing is the packed stuff. This is nearly there for the features. File enables packed support. Net enables packed support. It's unsupported for GPU, and it's enabled by CPU as well. For net target mode, we really benefit from packing our struts as small as possible. All modern compilers support the packed strut that removes all padding between fields by aligning each field to 1 byte. This comes at a cost of reading and writing to the strut. At a cost of reading and writing to the struts, as field is no longer aligned. That reads a little bit funny. This comes at a speed cost. Performance. When reading and writing to the strut, as fields are no longer aligned. Here's an example of using a packed strut. So you just put the packed in there and voila. So here's it defined with packed and without packed, and then talks about how the bytes span. So when we use packed in the encoder, we need to make sure right, I didn't put the error check in here. That's not very good. So here we've got to save the feature, target feature packed, right? So the packed directive can only be used when targeting. So when you're not targeting GPU, basically, can only be used when cannot be used when targeting when you target GPU. Oh, this is so fiddly. All right. Sweet. Right. Glad we looked at that one. Anything else that stands out from this? Yes, there was that target thing when we actually processed the target directive at the top of the file. I did a thing where it said if it was GPU. We parse the text thing, isn't it? Huh. Yeah, where do I check for text in GPU? Did we do that one in the end? Can I have a text format if GPU is specified? Where did I put that error? Ah, that's done here, isn't it? Right, so this is even before we build the feature flags. Right. Okay. Sweet. Right, so packed is done now. Non 4-byte basic types. So these are basically enabled for everything except for GPU. So this wants to support a wider range of GPU hardware, restricts to basic types of U32, S32, float 32 bit fields will always be 32 word, and vector types will be same basic, have the same basic type restrictions. So how are we going to support this one? Hopefully it's not too fiddly. So we already initialized the type tables with, so every single time you parse A, we've got underlying types. We've got underlying types to worry about for enums. And we've got structure fields and union fields, which is basically the same code, where you can specify other basic types. So I think it's just a case of targeting those two places in code and putting the checks in. Yeah, I think that'll do it basically. And then the bit field one as well. Yes, I remember that. Right, I'm just gonna go and get another drink, and then we'll carry on with this one. Right, BRB. Right, welcome back everybody. Okay. Right, so we've got to check all the basic types, all the fields in that, and make sure that we're not using a type which has non 4-byte aligned types if we have GPU. It shouldn't be too hard to do. So we could just make a function that does it. So we should just be able to make something where it's like bool type ensure. So we say, hey, if GPU, then you just go ensure non ensure 4-byte type. Something like that. So it'll be recursive. So we should just be able to... Oh, wait a minute. I don't think we handle recursive types well in our code. I gotta really be really careful of that. We need to write that one down. Do not allow recursive types. So you kind of have Mr. Beast. Who's that? So I guess we'll do a super switch. And then we want to right, so this basic, we're going to check. Fail equals false, I guess. And we'll say if fail. And we'll write out the thing, right? So it'll be that exit. What have we done at the reader level? So text reader. Reader. Something like this line here. I always messed that one up. Right, so say the non 4-byte types, 4-byte aligned types cannot be used when using the GP target. So effectively this passes fail if type basic is not equal to type or basic type U32. Or as Mr. Beast is the richest guy, you're the smartest programmer. Thank you, sir. Appreciate it. Not sure what would be compared to Mr. Beast though. But I appreciate the compliment. How are you doing, Sanya Old Oven? How are you? These are ands, not alls. So it fails if the basic type is not one of those. If it's packed, it's the same thing, right? Of this basic type thing, we could have done a lookup table. That probably would have been a good idea. But yeah. You know, we could just be like, you know, screw it. Let's do this. Do the good idea. We should probably make lookup tables with size and align. Sorry, size and align. All right, got our cheeky lookup table. So we just hop back into the ensure 4-byte basic type. This one. If that's not equal to 4, then I've got a problem. So this would be basic, sorry, packed, unpacked basic type. So this is our bit packed stuff, proper nice. So for structure union, these ones want to do a super lovely recursive thing. So you have to do field index 0, type strut fields count, and then we simply fail or equal type ensure. No, you don't fail or equal. You simply just call ensure, and that will. Well, let's be honest. These ones can just break because every single structure or union is checked, and all the intrinsic ones only have 4-byte aligned types if there is a built-in structure or union. Like our vectors and things. Sorry, not vectors. Oh, no, our vectors are in here. Crap. Right, so only if this is a built-in type. If type is intrinsic. Right, let's just go over it. It's going to be a little bit extra code, but it's okay. So the type would be type strut field index.type. So you OR it onto there. We don't need to OR it, you just check it recursively. Off you go. Enum. Fail or equal basic type size of line. Type enum underlying type. Well, that would have already been checked. Well, maybe you can do. No. But we'll do the check anyway. But it will get caught another way. Arrays. Or maybe we just say like, this is checked when defining the underlying type. Yeah, maybe we'll pass in the type table as well. And then actually we only have to do this if type is underlying type. Sorry, is an intrinsic type. Man. Yeah, then we'll save doing the extra iteration. Do nothing. Arrays. I'm going looking for someone on Twitch and I see you. You definitely look like Mr. Beast, so this is your channel. Fair play. I've been given many names. Many lookalike names. What do you do? That's alright, no worries. I say incorrect English all the time. What do I do? I'm a software developer. Well, I'm a graphics programmer. In the games industry. But in my spare time, I also like doing more programming, working on my own projects. So here we're just working on my own game, basically from scratch, without an engine. So we have a game engine that renders ellipsoids at the moment. All written from scratch in C. It's got a custom shader compiler as well, so we can write shaders in C. We've got PBR, so it's physically based rendering. So we've got kind of realistic looking lighting in a way. We could do a way better job, but we've got the basics going. But yeah, bit glitchy. Got some entities, they're moving around. But yeah, we're gonna be working on some editors so we can actually make models and then get back into finishing off on the rendering. So I need to have a way to make models and levels that actually make content. Because right now we've got a very custom renderer and we only can hard code content in code. So yeah, we're just building the encoding thing, which is like this system which allows us to like encode data out to text files or keep it in binary, and also do versioning and do a bunch of like error checking stuff. So yeah, we're just wrapping up on that, and then we'll be able to get to actually working on some of these editors. So yeah, doing a lot of custom technology. It's a load of fun, and yeah, getting towards building our own custom editors and hopefully get a really nice, distinct looking art style, which will set us apart from a lot of other games. Hopefully, that's the idea. Array types. Arrays are built with structures, but you always check the base type anyway, so you don't need to check arrays. This is checked when defining the base array type when parsing struct/union fields. So we don't need to do any of this checking. That does nothing also. All right. Sweet, so we've got this nice function now. So only intrinsic types need to be checked since struts get checked as they get parsed. Thank you, appreciate it. Yeah, I'm gonna keep going. I'm enjoying this. Plus, I could probably turn it into my own thing eventually, which would be cool. So yeah, it's very sad news. I don't know if you follow the game engine side of things, but Bungie, not Bungie. Who was it? 343. That's it. We changed the name to Halo Studios or Industries, whatever it is. I'm butchering this. And they decided to ditch their custom engine and go to Unreal Engine 5, which is quite sad news actually. I think a lot of the gamers are like, "This is amazing news," but I feel like it's basically a net negative for probably everybody. It's quite sad. Like, it's one of those things where they probably were capable of having their own engine. And all the things that they mentioned, the reasons why they switched, is not going to make Halo a better game. Like, they're like, oh yeah, what made Halo great the first time around was graphics. That's what we need is good graphics. And that's not what the problem with Halo was. So yeah. And they were also saying that weird stuff like we get to use like industry standard material systems now. But you know, they had like 400 employees. You think they could have implemented that in their engine? Probably could have. But yeah, sad news. More custom engines dying. So we want to do this check when you parse a structure field. That's one place. SF type, structure field type. Yeah, agreed, it's a shame. Hey Pete, good to see you. Yeah, you know what I honestly think the main driver was? I heard reports a while back that Microsoft hired a bunch of temporary people to work on games such as Halo. And they hired them for like 6 months. So they would hire them, train them up, and then they would just get used to the engine, and then they would have been let go. Um, so they basically went through a lot of temporary talent that got trained and then got released. So I think one of the big problems they want to solve is like, hey, we can just hire Unreal people. Um, you know, apparently their engine was in quite a bad state, though. I did hear a lot of bad stories about that. But I still think you can fix it. You have 400 people on payroll, 10% of which are probably, 20% of which are probably engine programmers. So that's 80 people, at least. Like, they must be able to make, because I think in that Unreal thing they demoed, right? They spent 2 years from what I remember hearing. I might be wrong on that. I think they spent 2 years working on that Unreal Foundry thing, whatever they called it. 80 people for 2 years. You could build an engine. You could build a new engine, which is not really a new one, by taking the good parts of the previous engine and replacing still starting from scratch, but copying the bits which make sense and refactoring it. 2 years, you do that with 80 people. And then you can own the technology. Don't have to pay royalty fees. Yeah. Mhm. There was a vid about Bungie working behind the scenes talking about a 10-second gameplay loop. Huh. What is what do you mean by that? Xbox dev. Can you link that if I can see? I think the industry is cutting cost. The main reason behind it. Possibly right. I don't know. I think there's a lot of perceived benefits using a hand-rolled engine, and it's one of those things where it's like, Um, like, hmm, like there's that mentality of like the grass is greener on the other side, right? It does these things better. So you would happily ignore all the potential benefits that you already have that you will literally be getting rid of. Um, there is definitely that. It is a cycle, but I wonder if we will go back to loads of custom engines because my main concern is engine development gets more complicated over time. You have Vulkan, that was a big complication. It took a lot of time for people to learn. Some people still don't know it, and it's the thing they've got to learn. It is kind of on that complexity level of indie devs should probably just skip it and use a high level wrapper. Um, and it gets to the point, right, where people making platform APIs are a bit like operating systems. They can just be like, we can make this thing a little bit more complicated because there's only like 3 engines, and only these 3 engines have to implement it. So I hope we don't get to a place where that is a thing. Okay, have a good night or day, and success your engine. Thank you, Sani. Sanyam. The environment went back, then looked pretty sick. The entire environment went back, then looks pretty sick to work in. Not sure you mean an Xbox dev. Can you clarify? Right, so we parse a type. Where do we parse type? Is any one place? Right. So when we parse a type, we could just do it here. If we'll just do outside. Ensure for by yeah. So if I'm gonna put in a good place in it. Okay. If file, so we'll do like not file target feature flags. Non 4-byte types. Right, so ensure non 4-byte type reader type table structure field type. Right, so that's one place where we need to do it. The other place we need to do it is in the when you parse the underlying type of the enum. That's a little bit further up or down. It's here, right? Oh, for crying out loud. We do need to check enum. Cool. Because we pass the enum in here when we check it. So structure fields, enum underline type. Bit field is the other one, isn't it? Bit field, hash bit field. Oh, I've already got the check in here, right? I've already done it. Past Henry's got me covered. If it's not equal to, yeah. Sweet. Right, so we got that one checked. That's good. That was a little bit fiddly. Could maybe give that a go. Just remember that version thing. That hash version only in database file. Yeah, so it's not a database, it pushes on a version. And we should say, if not database or versioning is not enabled. So if there's no versioning, you push on, yep. So in the database file, there's this version thing that gets parsed up. This can only happen when you have the versioning flag on. This one here, right? So if you got a feature, if there's no version, the version directive can only be used when there's a file on net target. Right, but it's only used by the database. We'll try that out. Okay, so that's a good change. So never push on a version. Something that makes me angry about Dwarf Fortress is that FPS tanks due to so bad due to whatever reason makes me upset. Really like the idea of the game. Yeah, I think they do a lot of logic, so that's really expensive. And I think there was some guy hired to sort of help multi-thread that, so it must have been made better. But yeah, I must. As you talked about getting good gameplay, yeah, Putnam, that's the guy. Yeah, making a good play going, and then extending it. Ooh, 12 years ago, amazing. Can I pause? Okay, 26.6 decibels. Minus 26.6 decibels. Let's get back. No. Too much rock and roll. If you can get 30 seconds of fun, you can stretch that out to be an entire game. That's an interesting take I've never heard. Right, I think that was the clip. Interesting. Interesting. Yeah, just copy paste it. Ought to be good enough. You know, that's what Fortnite is, right? That's all you do. Play the same thing over and over again. But yeah. I see the point. He's basically saying like find the good core bit about the game and then keep doing like make the core bit about the game fun. Like the good 30 seconds is shooting enemies, being able to dodge around. Um, you know, you got all these different types of weapons that you can use, I guess. Um, and if you die, it's got to be something where you really want to get back in there and do it again properly or something like that. I guess that's yeah, like you know, the graphics is not what is not what is going to fix Halo, right? Um, you know, and say if they enable these features in Unreal Engine, how good is their FPS going to be as well? You know, and you know they're going to have to fork Unreal Engine because every game developer that uses it in AAA at least has their own fork of the engine and they make changes to it. They have to maintain their own patches to that code base. With Unreal Engine comes Unreal compile times. That's another thing as well. Got to deal with that too. Right. Did we get that done then? Yeah, we should test that out. If I delete the database file. Now let's spice things up a bit. Switch over to GPU. And let's see if stuff goes new. S16. Cannot have text. Non-4 byte type not allowed. That's on line 4. Right, so we've got that error. That's good. Let's delete that one. Line 14 is the next one here. Let's try it with a vector just to make sure we've got that. So, and line 13. Boom. Cool. Got those checks. That's good. I'm happy with that. What else do we want to support? Oh yeah, let's see. So let's get it working. Let's get an output in a database file quick. Let's make the necessary changes. Just by deleting everything. What have I done? 15. Yeah, so I think another problem, right, is we don't have if defs. Oh, we need a root. Right, let's make this one the root. Because it's got the file one on it. No, but file's got versioning. I don't want versioning. I want to test out the database file. Right, the magic directive is only used when there's file. Right, so we deleted the magic directive. Boom, it works. Just go to the database. See for the database. Oh, let's reload it. It put out the version, that's what I didn't want to do. So now if I run it again, it's going to complain. Yeah. So I forgot to do that. So in save database file, we only want to put out the version if file features target features version. Alright, so let's delete that database, run it again, reload the database. Right, now that's missing. Can we keep running it? Yes. So because we don't have versioning, we should be able to make changes. Right, so if I go to the enc file and I delete a line, this is saying, hey, you deleted something, right? But we don't have versioning, right? So we shouldn't be able to. This is something I remembered yesterday, and I need to remember it today, and I forgot it. But I'm glad I just remembered it. So actually, when we're doing that sort of merging, right? So actually, right, if we don't have versioning, you might as well not save anything out. It just doesn't make any sense. Everything is always fresh and new, basically. So don't save anything out. Just delete the database again. Just give it a run. Run it again, and it just keeps working. Right, we can just make changes because when you just support GPU, it's just all in memory. You don't need versioning. But as soon as you put file in there, it needs versioning. So here's the database file. Let's reload it. It's just got target GPU binary at the top, and we don't really specify anything else in there because we don't need to. But this exists such that if we change the target in the enc file, it will check against the database and it'll be like, hey, this has changed. It cannot change. So yeah, it's all right. It will do. Right, I'm glad we remembered that. So let's go back to what we had before. Because what we had before was, well, we need to do all the testing around different versions and things. Yeah, the versioning thing. So I guess we can test these out in a bit. So we did these last stream. I would like to test them in just a minute. Is there anything else we can remember quickly? This is all the different rules that we'll follow. Well, you know, maybe we'll quickly do them. So for text files, right, so if you make your database. Oh crap, what the crap happened here? The null pointer. Did it really return a null pointer? Level. I'm running that again. Oh, it's looking in the why is it looking in the destination? That's incredibly wrong. Oh, no, that's right. It's got to search for in the destination. Right. So here we decode. Sorry, here we have found the level, the root type basically, and then we go over all the fields. It's got a variable length array, and the root type is trying to find the reference to, but it hasn't inserted it yet. So we should insert it first. Right, sort that one out. Merge. So if you've got a type that doesn't exist, put it in the type table, then do some translating for it. Translate all the stuff over, right, okay, it seems alright. That fixed our problem. I don't think we've got anything else. Oh, another sec fault. Oh, it actually tried to save stuff out. Interesting. Right, so in the middle of saving stuff out, what did it do here? Zero. So it didn't find it. So it didn't translate over the enum values, is that true? Oh crap. It was working. Right, maybe because I didn't delete the database for a while, we've added new things and it's just not working from scratch again. Okay, so the enum values. Right. When it's in the translate, it's yes. If it's an enum, it tries to type table find value of that ident. Right. So what's going on is when we have an enum. Oh, for crying out loud. See, those global. When we globally find an enum value with an identifier, it's problematic when you add no, it's not problematic, I think. Yeah, maybe it is. So rather than inserting them in and copying them over, we're just saying make it point to the source type table, so the one in the .enc file instead of the database. Yeah, so maybe what we should say is if it can't find it, look again in the source one. Bit sketch, but it should be fine. Translate if you can. If not, just leave it alone. So enum value EV. We'll do like an EV equal that. Then set it. Same thing again, but for max. Okay, that'll be alright. That should fix our problem. Is the database bin there? Let's delete it. Okay, so it ran successfully. Let's double check it quick. Let's get into the database. Give it a reload. And the enums seem to be okay. So, and these enum values seem to be okay as well. That was where the reference. Oh, these ones were the reference were happening with. Yeah, so they all got created properly. That seems good. So we're back in business. So let's get editing the file and just make sure the checks work out. So the rules are, we've got text. We've got text. So we should be following these rules. We'll try the binary one afterwards. So we should be allowed to add structure fields and enum values. So let's add mouse2. Let's add so you can also kind of reorder as well, isn't it? Change. Right, the wording on that is a little bit weird. Change default values. You can also change order. Strut/union fields order. Change enum values. Yeah, they're actual values. Right, let's go. So let's add a new one, new field. Right, let's run it, see what happens. Right, that ran successfully, no problems. But let's check in the database, see if those got added. So what mouse2 got added at 5. A new field got added as well. Cool. So let's go to, let's try the reorder thing. We're going to reorder mouse and mouse2. Mouse2 is going to come first, and the new field is now going to go at the top. So let's save that, give it a rerun, go into the database, give it a reload. New field is now further up. And then notice how mouse hit changed from mouse to mouse2 because the range. Mouse2 is now 5 instead of 4. So you can change the enum values in text mode because in text they're encoded as the actual string rather than the number. The number is binary form, right? So you can make these changes while you're in text file. If you're dealing with text files. When we have text and binary, when you put it into dev mode, you're making the binary file. But you can make changes then to anything you want. So you can just change everything. And then when you end it, it will put it back into text mode. So those are some good changes. Then they were tested working, so you can change the values, that's okay. You change the orders, fields, change the packed bits min-max values. Right, so let's change this to 100 and change the min-max values, change the number of bits. Right, that seems to have worked. Let's hop into the database. Give it a reload, and that changed. Sweet. So you can change these because this is again purely for binary, but the thing you cannot change is the actual data type. You cannot change that, because if not, that will be some incompatibility when you save it out. Because in text, you'll just output 16-bit in. Change the enum underlying type. Make it assign date. So in the database, it is assigned 32. Let's watch it change. Reload. Oh shoot, that didn't change. Right, so this is a good catch. Inside the merge function, the type tables, we've got to be extra careful. So when you process the enum, if it's text, right, we didn't copy over everything. Destination type enum dot underlying type. Source type enum dot underlying types. So is there anything else? There is a values min and max. That's quite dangerous. We didn't copy those. So those values min max. Yeah, we need that. Cool. Same up there as well, actually. If in dev mode, just copy it all over. Nice. What about the structure? Did we miss anything with the structure one? So structures have is packed. Right, that's a problem. That's something we've not done, is it? We've not added checks for that. Oh crap. So if you make something a root object, the root object cannot change as well, isn't it? Something like that. Right, these are things we've got to check. So with versions, you can change the root object. So in dev mode, you can definitely change root. There's nothing else, was there? Bit filled word type. It's another interesting one. All right, let's jot these down because I'm going to forget these. Right, so you can change the bit filled word type. You can change, you can add, remove, packed. Right, but you cannot, when you change the root type. So for binary data, that's the same problem. You have, if you require, you will require a version upgrade if you change the root type. So you'd also require if you change add or remove packed, right? Or if you change fill T, right? So we need to implement those. Oh, that's something that could have been quite bad. Right, so okay. So it's on the structure as a whole. So let's start with the common one. The common one is if dst type strut is root is not equal to. So the thing is about the root one, if you delete the root object, it'll tell you can't have one. Equal then not equal. Yeah, I think this is right. This is fine. Is root. So we'll put an error out. So what we'd like to say is the root object cannot be changed in the database is this one. So gen.type, so in the file, in the source file, you actually have the root type. So we can just put it there. We can then put in the source type so if it was the root type and now it isn't, it's going to point to yeah, we should always point to this root type. So basically strut identifier is the root type, but the directive has been removed. It's saying it used to be this one, but it's been removed, or changed, but it has been changed to another type. Wait a minute. You got to do the one in the database. Database root type. Yeah, then you do the location with the one in the file that it thinks it is now. Is the root, but it's changed to another, and we'll point to that one. In the data, okay, that's good. If you'd like to change the root structure type, put the file into dev mode. This will force a version upgrade. Nice. So that's the one check that we need to do there. And that one is going to be for both text mode and for binary mode. Now, if you add and remove packed, that's a problem, and change the bit field underlying type. That is a problem. Yes, we changed the underlying type for binary. That was that. Right, okay, that's cool. Let's copy that one. So for text, sorry, for structures and unions, binary. Right, if you change the is packed. See, in that error, I didn't do like if you'd like to change blah, 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 blah. Because you can change the underlying type, it's not a problem. And did I put that in the, yeah, it's in the docs, that's good. If you'd like to add or remove to change the underlying type for the enum, put the file into dev mode. Cool, and that'll force a version upgrade. This needs the same sort of thing. If you'd like, right, so if it was packed, if the packed thing changed, so structure identifier, packed has been changed. If you'd like to, has been added or removed. If you'd like to change this, strut, put the file into dev mode. Right, so there's that one, and there's the other check, which is the wait, crap, what source type goes into there? Source type, yeah. Yeah, so the next one is the bit field word. So I guess that defaults to U32, perfect. So if that differs, that's another one as well. Have I got a we'll put the DST type in there because I think in the print format we can do a custom format thing where we can say we'll do a B, TB, type strut. What's that word type again? Is that a basic type? It is. Good, 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 good. So we'll put a B there. Cool. Back to here in the error check. So if this doesn't match, bit field type has changed. Bit field word type has changed. In the database, it is TB. If you'd like to change this strut, put it into dev mode. Nice. So I think we also would like make sure we copy all the things over properly there. That's good. I like it. Right, so I think we did those. Okay, so back to the text ones. So we double check those errors. So we should be able to change default values without upgrading. We should be able to change the underlying type. So if we run it now, go to the database. The underlying type should change. Yep, to S8. Amazing. So let's go back to the ENC file and test the other changes. So you can change the bit field type. So let's do bit field. Yeah, so if you did S8, that's an error, isn't it? You can't have signed. Yeah, it must be unsigned. So did U8? Great. So we go to the database. Give it a reload. we're not writing this out here. I can't see it in the database. So in the generator, when we save out the type, we need to put out if a word type is not equal to basic type E32, we'll do bit field have we got strings for these? Basic type strings. Alright, it's alright. So that should do it. Let's give that a go. So let's hop over to the database, give it a nice reload. I don't see anything still. Did we make it a U32 then? I did a U8. I don't know if we're copying the type. Where is it? Oh, right, you should be able to make these changes, isn't it? Right, so this text you should be able to change. So for enums, what did we do? Oh yeah, we just made the changes, right? So this text. There, man. What? Let's make it be explicit. See what's going on. Let's make it always print out. Right. Right, so it really is that, which is strange. Alright, what have we done that's clearly wrong? Is it pointing to the wrong type? We could put a breakpoint in. If string source type ident, what's the one? Got it in there. Ent enc, I think it is. Or break. Right, let's hop in there and see what's going on. So it's text, goes over all the fields, does its business. There's actually quite a few fields, so why don't we continue down to here? So the source type, well, let's just keep, it'll tell us. Right, I don't think we're parsing it properly then. That literally must be it. We're not parsing. If it's not happening, if it's not the right value there, we've literally just not parsed it right. That's all it is. Right, so defaults to that. Oh. Oh. Parse directives, this is it. Bit field. Oh my days. Surely it's being set correctly. What the crap is going to type basic? Ah, you bugger. Shadowing. Okay. Cheeky shadow. And that should fix it. So hop over to the database. Reload, and voila. We got it in there. Bitfield U8. Fantastic. So the next thing we should be able to change is the packed stuff, and we should try the ooh, yeah, okay. We should try adding and removing packed. So packed should be able to be added. Reload. Switch over to the database file. All right, packed got added, no problem. Very nice. So what is next? So that we've just verified that that all works as planned. We can make those changes, no problem. Okay, so next things, the one things that will cause breaking change that will need an upgrade. So changing a struct field type. So we simply change this new one that we've added to U16. Right, that's the problem, right? Yes, we cannot change. New field type mismatch in the database is U32. If you'd like to change, yeah, put the struct into dev mode. Nice. Reuse a removed struct field with a different name. That doesn't exist anymore since we don't support removal. So in documentation, we need to change that. So yeah, you can't remove or rename a structure of union field. And the reason is because if you change it and you've saved that data with a field name of health, for instance, and we called it health 2, that value I'm going to read is going to be made invalid, like it's just going to be forgotten about. So if you want to add health 2, you literally just make a new field called health 2, and this one you just say like as a comment that you're not using it, and then when you do the upgrade in the future, you can just clean it all up. You can clean it up and do a proper upgrade. No problemo. So let's try the health 2 field. Did we try and change default values? I don't think we did. Let's try that. Change that to 10 quick. Right, default values are okay to change, that's good. Change that to 2. Segfault. Well, it kind of works, right? But yeah, the segfault is because we didn't set a local type. Oh, I didn't do it in a few places. Get in there. Right. In the merge function, We're merging some stuff over. We're not setting some of the format things properly. So let's copy that line. Yeah, these two lines. So context aware printing is now set up, so we can use these dollars for things. So field identifier for the database. Yeah, I'll just try that out on this one. Is that one? That's right. Oh, let's give that a go. Another segfault. What is going on? That was another one. Oh, a structure field. Is that null? Right, that's a weird one. Yeah, structure field is null. See, it's DST. Field has been removed. Perfect. So ENC field health has been removed. If you'd like to change the strut, put it as dev mode. Cool. This is force a version upgrade, and that's fiddly, right? You don't want to do the version upgrade all the time. So that's looking good. We just renamed the field and it reported an error. So we put it back, no problem. So the next one is rename remove. Let's drop field rename remove enum values. Right, did we not? Oh yeah, we was allowed to add them, that's fine. Yeah, we tested that, but we did not test removing them. So let's rename one now. So we rename mouse to mouse with a 3 in it. Be extra confusing. And let's rename. Yeah, you can. Yeah, that's it. We've already tested the field one. Right, it's another segfault because probably the same problem again. Alright, I didn't set the context aware printing up. So it's destination type destination EV. Yeah. So destination EV because this is when the source EV doesn't exist. And then it'll do the proper nice error. Cool. So ent type mouse has been removed. Cool. So put mouse back, and then everyone's happy again. But you can move them around, right? And that's all okay. Because otherwise, when you parse a text file and you got a mouse, what do? Do you put it to a default value, right? So that's why we got that. Got that there. If you change the tag or key names, to change the tag to be maybe defense. Tag mismatch. Yeah, so it's changed it. So that's so I got that checking and that's good. I guess the key must be an enum, right? I think the tag, yeah, I think that's something we should. Tag should probably always be an enum. It could just be equality, right? But yeah, maybe we'll just do it for enum. It makes the most sense that way. So let's find tag quickly. Right, so you should then say if structure field tag kind is not equal to enum, and it's another reader error. Oh. All the dereferences. Yes, so here we're saying that the tag unable to locate. Right. Tag field is not an enum. TI. The context we're printing tag type. Cool, so we put it back to defense. Here, and then run that again. It will say that crap. Right, it's an integer, isn't it? So I could say is not an enum. That'll do the job. Wait, ent type. How's it saying? Ent type is on enum, but we go in the defense. What? So it's parsing the string. Nothing's happening to the string memory, right? Alright, now it's a segfault because it may or may not. It hasn't been set yet. Let's just print it out here regardless. It still says ent type. Oh, did I edit the... Did I do something silly and not save the file or something? Nope. Let's put a 2 on there, double check it. Oh, is it? It's in the database file, isn't it? Oh. Okay, so that's looking at it in the database file. Int type is not an enum. It is, mate. Put a breakpoint in there, I guess. What kind is it? It's a packed type? How the crap did he get that? Did he get the wrong type all along? Do we already get a hash collision? That would be interesting. It stopped on what again? It ended up grabbing one on the strength or range. It must have done. It was a packed type. So, let's have a look at that one. P. Let's look at 3, 4, 5. Alright, what have I got here I didn't hash? Right, it's definitely what 5 is. Zero, 1, 2, 3, 4, 5. Oh, right, but it's a packed type. It is a packed type, it has an enum in it. Okay, well, I'm glad we caught that. Or okay, just call it T. So the T enum or T packed and T packed unpacked type kind is enum. Right, that's a good check. Ah, I put an equal sign on there, didn't I? And I can't be asked to revert that logic. Okay, it was not equal to an enum. And yeah, the inverse would just be not equal an or in it, wouldn't it? Let's just do that. Cool, so if I change the thing to defense. Right, defense is not an enum. Excellent. Cool, right, we're getting closer to these checking off all these things. The following require version upgrade. So changing key names. Change a key name. Let's. So we change it to a mouse. Yeah, so it used to be. Yeah, it used to be mouse, but now it's. Oh, for crying out loud, it's the wrong way around. That's in the merge code. Enum. No, it's not enum, it's in the parsing code when we parse the key, isn't it? Ooh, it is in the merge when you merge. As for structures, that's it. So if the keys mismatch, swap those two around. Same with those two. Right, so match key mouse mismatch in the database, it's pig. So you can't change it, right? Nice. Cool, put that back. So that was all of them, wasn't it? You can't change the root type. Yeah, can't change the root type. It used to be level, but now you've changed it to here. Just let you know that. Sweet. So we've got one more set of changes to look into, and that is the binary files. Well, the text ones make sense. So just thinking if we got the versioning thing right. So we only want to save out to the database file any history. If you have versioning, that's it. Then no upgrade should probably delete the old stuff, I think. Yeah, okay. Yeah, that's for future. Right, so let's nail these. So let's switch over to purely encoding for a binary target. So to do that, we'll delete the database. And we've got to change what the file actually is. Right, so we're only going to be output in binary now. So let's just see the swap of errors we'll get. So you can have default values. Yep. Let's make sure that makes sense. So you cannot have default values. The hex directive cannot be used either. You know that key. Neither really can the key or tag, to be honest. Key or tag shouldn't really be there either. We should sort that out. That'd be very misleading if we just see those in there, you know. What was that thing again? It was the hat. It was the hex, wasn't it? Hex had that check. So for tag and key, they need the same thing. Tag directive can only be used when doing a text format. And then so can key. So we get 2 new errors there now. So remove these keys. See, and that's another thing as well, is like packed types. You don't really need packed types for purely text files. We should definitely write that error out. So, okay, that was in the database file, it's parsing that. But yeah, let me write that error out quickly. So, when we're doing the packed stuff, parse type. Oh, shoot. So here, we should do a thing like right here, where we go, if you've not got binary, then why you'd impact types? Doesn't make any sense. I need the file in here. Gen file. Yeah, so what we're saying here is packed types do not make sense. Packed types. Same with bit filled, really. Same with enum values. Maybe? No, they're okay. Because you want them in the source code that way, maybe. Pack types do not make sense. Well, you could have them be packed inside. No, maybe they're fine. We're not gonna put that error in. The reason is because CPU side, you might want to use it for some reason. Yeah. Like in memory, I don't know why, but you might want to do it. Right, so let's get to these actual checks. So the two things you should be allowed to do is rename. Just rename fields. Just be able to rename them because it's all about being API compatible. So we get to the encode stuff. We've not got a database file, so we're going to run it. Oh, hang on a minute. I did a silly. All right, we're back in business. So we would have produced a database file now. So we should be able to literally rename stuff, no biggie. So if I were to change this to mouse 3, and this to coord 2, okay, that's a problem. Where is it? Yeah, so if we rename the enum value, it's used as a bit field. Sorry, it's used as a packed type. And because of that, we put the values. Yeah, maybe we should encode them as integers. So in the database file, the problem is this is explicit. The range is explicit here. So unless we don't do this, we put out the explicit range. So if you are to change But this is purely for min-max. But you should be able to change these names in binary mode. So if we specify like 0 and 5, you then have to traverse this and find it. Yeah, maybe that's something we do. Right. I think I might put a pin in it here today. So make good progress at least. Did a lot of changes to the validation stuff. So in the next few stream, or in the next stream, we'll be able to wrap it up actually. We'll solve this problem with the renaming enums. It's not working. We'll verify all these work. Then we'll be doing the actual versioning stuff, like actually testing upgrades, like the logic for it. Like when I put it into upgrade, does it make new structures in the database, right? When I do no upgrade, does it discard all the past data, right? If I do amend, does it amend the structures on that current version? Just make sure it all behaves well and obeys what the docs say. Yeah, maybe we can get started. If we go through all this, we could maybe get started on. Oh, yeah, got to read through all that. Maybe there's some other things we'll find. But then we should be able to get started maybe on something else after that. So we should at least be able to wrap up on this encoder system validation side of things on Thursday's stream. So that'll be at 7:30 p.m. GMT +1 on Thursday, and then on Sunday at 6 p.m. GMT +1. So on Sunday we should actually beginning the part of the code where we actually make C code and begin to actually see this thing create stuff. So yeah, it's getting there. Quite complicated, but it's for the good of the code base. It's gonna be pretty sweet. No worries, P-Rex. Thank you for coming. It's good to see you as normal. But yeah, so for those who support me, thank you so much. I'll put the code we've done so far up on the GitLab as soon as the stream is over, as usual. And yeah, you're gonna come and hang out in the meantime and chat about stuff. There's Discord as well. Let's find someone to raid. Well, I might just bail. Alright, good night, Kit Payne. Good night, everyone else. I'll see you all in the next one. And yeah, have a good Wednesday. I got tomorrow off work. I'm gonna be chilling with the boy. And it's gonna be a lot of fun. Alright, good night.